Hello everyone. This is worksheet number 6 on hypothesis testing, and this particular worksheet has exercises on how to calculate the probability of type 2 errors, which is denoted by beta. So I'm going to first go through what the question is, and then I will explain how we will be working out this problem to find beta step by step, and then the power of the hypothesis test for the particular alternate mean provided to us. All right. Now, I expect that you have already viewed the PowerPoint video, which explains the concept behind type 2 error probabilities and also details the step-by-step process to arrive at the correct way of determining the beta value. So this is an example exercise, and it will further reinforce the process for you. All right. So it says here we have given a hypothesis testing situation and the population standard deviation, a significance level, a sample size, and some values of an alternate mean. Mu sub A stands for alternate mean. So the first part asks us to determine the probability of a type 1 error, and then part B says determine the probability of type 2 error for the first given value of mu sub A, again the alternate mean. And then C says to construct a power curve, but we will just calculate the power for the particular alternate mean we are working with. All right. Now, this is an example on the toxic mushrooms problem for which we had solved a question on performing a hypothesis test, probably in worksheet number 4. So if you cannot recall, just go back and watch that video solution on toxic mushrooms. But it was about the concentration level of cadmium in vegetables, which could prove harmful to animals, and that the governments of some countries had set the safety limit for the cadmium concentration at 0.5 ppm, and the test was to show from a sample of mushrooms. I think the sample size was 12. So based on a sample of mushrooms, if we could determine that the concentration was higher than the safety limit of 0.5. All right, so let's go through this. I just wanted to give you the background in case you do not recall, but we've already worked out the hypothesis test for this particular example in a previous worksheet. I think that's worksheet number 4 on hypothesis testing. So here it says the null and alternative hypothesis given on this particular exercises from the book are respectively null hypothesis 8 sub O colon mu equals 0.5 ppm. So this is the null hypothesis statement. And null hypothesis should always be written with an equals in it. And then the alternate hypothesis says mu is greater than whatever the null hypothesis mean is, so 0.5 ppm. All right, and they have given us some data points. So sigma, which is the population standard deviation here, the population standard deviation is 0.37 ppm. Alpha, which is a significance level at which the hypothesis test was performed, is 0.05, and the sample size equals 12, and they have given us a set of alternate means from 0.55 to 0.60 all the way to 0.85, with which we should be calculating our beta and therefore the power of the test. However, we will only perform or rather solve this problem for the first alternate mean given to us, which is 0.55. The process of finding is going to be the same for all the other alternate means. So this is just for demonstration purposes, so I will just use the first one. All right, otherwise it'll take too long. Now, the first thing that we must do is determine if we were to perform a hypothesis test, then what kind of a test this would be. The alternate hypothesis says it is mu is greater than 0.5 ppm. So this makes it a right tail test, if you recall. All right, it's a right tail test, and it is performed at a significance level of 5%, so alpha is 0.05. All right. Now, the first question says determine the probability of a type 1 error. So the probability of a type 1 error is whatever the value of alpha is. All right. So the probability, to answer part A, all right. So probability of type 1 error is 0.05. What does that mean? If we draw our diagram for the hypothesis test, we would be placing the null hypothesis mean of 0.5 at the center, and this doesn't seem to be quite the center, so I'm going to quickly erase this and redraw this. Just a second. All right, so maybe this is the center. All right, so the null hypothesis mean, when we perform a hypothesis test, the null hypothesis mean is assumed to be true, and we make sure that we do not reject a true null hypothesis. So assuming 0.5 is the true mean value, 0.5 will take the center point in this diagram. All right, and based on that, a value relative to that value, we will define our reject regions. Now, because this is a right tail test, the reject region will be to the right, correct? For a right tail test, the reject region is going to be to the right, so reject to the right, and therefore the other side of reject is going to be the do not reject region, and the area associated with the reject region is going to be 0.05. And when we find our critical value, because it's to the right, it's going to be a positive z value, which is z of 0.05, and that value I know is 1.645, but you can refer to your table or your calculators. If you don't have it memorized, then it's 1.645. That's the cutoff. That's the critical value that separates the reject region from the do not reject region. All right. And all this diagram, this area of the reject region, 0.05 and so on, is relative to the mean, the null hypothesis mean of 0.5 ppm. All right. Okay, so we have answered part A. The next part says we have to find the probability of a type 2 error. Now, if you recall what I mentioned in the lecture slides, I said that type 2 error is denoted by the letter beta, all right? And it is the area of the do not reject region. It is the area of the do not reject region. However, it is not the area of the do not reject region of this particular figure, all right? It is not the do not reject region of the diagram that we use to perform the hypothesis test. Why so? Because type 2 error tells us that in order for a type 2 error to happen, the null hypothesis mean is false, right? Type 2 error is committed when we do not reject a false null hypothesis mean, all right? So what the type 2 error claims is that this 0.5 value that we use to perform our null hypothesis test is in fact false. All right, and instead we have to use the 0.55 value. Okay, therefore we cannot have 0.5 at the center of our diagram when we try to find beta. Instead, this will get replaced by 0.55. All right, if we were using our alternate mean of 0.60, then 0.5 would have to be replaced with 0.6. And once we replace the center point with a different value, then this figure will no longer be valid. It will have to be rescaled. Our reject region will shift to the left, little bit to the left, little bit to the right, based on whatever value we use. All right, so we will have to redraw this figure, but before we do that, we must first find the x bar value associated with this CV, the critical value in the original figure. We have to find what sample mean corresponds to a z value of 1.645 in this figure that we drew when we were performing the hypothesis test. All right. So the first step is first find the z value corresponding to alpha, which is z of 0.05, and that we know is 1.645. Again, if you do not know that, please refer to table 2 or your graphing calculators if you have one. We'll have a statistical package where you can find these values, alpha values. All right. So I'm going to write here 1.645. Okay, 1.645, and that is also the critical value in the original diagram used to perform the hypothesis test. Now, step 2 says, now convert the z value to the corresponding x bar value. So what we are doing is, when the null hypothesis mean was 0.5, right? In the original hypothesis test, it was 0.5. What would be the corresponding x bar value of 1.645 z value? This is the z value, all right? The z value at 0.5 was 0, all right? This 0.5 is an x is the mean, all right, null hypothesis mean. The corresponding z value of that is 0 because it's at the center, and we just work with 1.645 as a critical value to differentiate the reject and the do not reject region. However, to find the beta value, we have to convert 1.645 to an x bar value. All right, and the process to do that is step 2. First, we have to determine what tail type this is. So it's a right tail test, right? It's a right tail test, and they've given us the different formulas we must use based on what tail type it is. It's for a right tail test, it's mu sub 0 plus z of alpha times sigma divided by square root over n. If it's a left tail test, it's going to be a minus, all right, instead of a plus. And then for a two-tail test, it is going to be plus minus, but we have to split our alpha into 2, like in any two-tail test. When we perform a hypothesis test, like in any two-tail test, you have to split alpha into 2 and then multiply by, find the z of alpha by 2 times sigma divided by square root over n. However, we are working with the right tail test, so we will have to use this formula to find the corresponding x bar value that goes with at 1.645. So let's do that. X bar is going to be mu sub 0 is 0.5, all right? It's not the alternate mean. It is mu sub 0. So I'm going to replace mu sub 0 with 0.5, and then plus z of alpha by 2 is 1.645. So it's plus 1.645. This is the formula we are using, all right? The right tail test formula. 5 times sigma is, what is sigma? 0.37, 0.37 divided by square root over 12, right? That's our n, square root over 12, n. So when you solve this, all right, we will end up with a value of 0.5. Hold on, let me just do the calculation here. All right, again, you have to perform this calculation first and then add it to 0.5. All right, make sure you follow the PEMDAS rules. So we will have 0.5, all right, 0.5 plus 0.1757. All right, that's the value after we calculate 1.645 times sigma over square root over n, and we will end up with an approximate value of 0.676. So that's the ppm corresponding to the critical value of 1.645. All right, this is the x bar value. The x bar value corresponding to z value to z equals 1.645, and that was true when the null hypothesis mean was considered to be true with a value of 0.5 ppm. So that was number 2, where we found the x bar value. Now that we have the x bar value, we have to redraw our diagram with the alternate mean. All right, so here I'm going to again draw a figure. All right, this time I'm going to draw a figure, but this time I'm going to replace my center point. This is a 2. Let me see how. Just a second. All right, okay, so I try to scale it the same as I done before. All right, so we have our, oops. Okay, so this is still our normal curve. Okay, but now we are going to replace the center point with the alternate mean, which is 0.55. So this is going to be mu sub a. Right, so 0.55, no longer 0.5, but we replace because the type 2 error says the null hypothesis mean that we used previously of 0.5 is false. So they've provided us with an alternate mean, okay, our alternate mean of 0.55, and that's what we are going to use as the center point of our curve. And then now we have to rescale our reject and do not reject region. So when we have an alternate mean of 0.55, now our reject region is still going to be to the right, but we have what did we find here? Our x bar value was here, right? X bar value was 0.676. So relative to 0.55, if 0.55 is in the center, then 0.5 that we used previously as our null hypothesis mean would will be pushed out to the left, right? It would be somewhere here, 0.5. And where would 0.676 be? It would probably be to the somewhere over here. All right, I don't know, maybe here, 0.5, 0.676. So let's just mark it here, and this is going to be, let's say this is where 0.676 is. 0.676, that's the x bar value, right? This is the alternate mean, this is the x bar value. Now we have to find the corresponding z value that goes with 0.676 after we replace the center point with the alternate mean. Okay, so let's find what the corresponding z value is, and here's the formula for it. Z equals x bar minus mu sub a divided by sigma divided by square root over n. So what you're going to do is just plug in the values. X bar is 0.676. So we are trying to find now the z value of 0.676 relative to the center point value of 0.55. This is where it is. All right. So x bar is whatever we found in step 2. So 0.676 minus, you have to use 0.55, no longer 0.50, because that has been replaced by 0.55. So 0.55 divided by sigma is 0.37 over square root over 12. And when we do this calculation, we will come up with a value of 1.18. And that's our z value corresponding to an x bar value of 0.676. All right. So this value here now has a z value of not 1.645, but it has a z value. And let me just erase this and just write it a little bit, space it out a little bit. So the x bar value was 0.676. The corresponding z value is 1.18. Right? It's 1.18. 1.18. That's the z value. So what has happened is 1.18 is closer to the center point now. So what has happened is this area, which was the reject region, it's still on the right hand side, but now it is a wider region, right? It has increased from, this was a much narrower area that the reject region occupied. Once we replaced 0.5 with 0.55 and calculated our z value, we get a wider area for the reject. And the other side, which is the do not reject region, is going to be the area or the probability of the type 2 error, which is beta. All right. So beta is going to be the area of the do not reject region. All this area is going to be our beta. All right. It's going to be our beta. So that is the next step. So I hope you understand the first 3 steps, because those are critical. All right. So once we have our z value of 1.18, the next step is find the area of the do not reject region. So the do not reject region has a cutoff of 1.18. So the z, all right, the new CV or the z value is 1.18. All right, and beta is area to the left. So if you consult your table 2, which always gives area to the left, all right, just find the area corresponding to a z value of 1.18. And so area to left of 1.18. That's what beta is for this particular problem. Area to the left of 1.18 is 0.8810. Okay, and then finally, if you are asked to find the power, this one doesn't ask, but let's say there is question 5. I think that's it was a part C. All right, so part C said find the power. So the power is easy. Once we have the correct value for beta, it's going to be 1 minus beta, or 1 minus 0.8810, which is equal to 0.119. All right. So that is the step-by-step process of finding beta. But to find beta, just keep in mind, you have to rescale your diagram based on the alternate mean given to us, and then find the area of the do not reject region.